Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to talk about effective and equivalent interest rates. Let's say we had $1,000 principal, which would be our present value, and we invested it in different accounts for a year. One of them had 6% interest compounded annually, one was 6% compounded semi-annually, 6% compounded quarterly, and 6% compounded monthly. They're all the same interest rates, but because of the different compound periods or frequency of compounding, the future values are going to be different. Specifically, that $1,000 after a year would be equal to $1,060 in this account, $1,060.90, $1,061.36, and $1,061.68. So although it looks like the interest rate's the same, it certainly isn't. We need a way of comparing interest rates, particularly because they have different compound periods. In order to do that, we calculate what's called the effective interest rate. These interest rates are called nominal interest rates. They're also called APR, annual percentage rate. But what we want to do is change them to an effective interest rate or effective annual rate, or EAR. Lots of letters, lots of terminology. It sounds confusing because of the letters, but I'll remind you what each rate is as we go through the examples. The definition for the effective annual interest rate, also called EAR, is the true annual rate of interest, including the effective compounding for a loan or investment. The effective rate of interest is always compounded annually. So what we need to do is take the loans or investments that are not compounded annually and find out what the rate would be if it was compounded annually. The formula that we're going to use to calculate the effective annual interest rate is equal to 1 plus I, where I is the nominal interest rate, or the APR, divided by n, which is the number of compound periods in a year, raised to the power of n minus 1. Let's take a look at some examples because I think this will become easier once you see how we use this formula. So our first example says find the effective rate equivalent to 6% compounded monthly. So what we're asking for is the effective annual interest rate, also called EAR, when you're given the nominal interest rate or the APR, the annual percentage rate. So what we're basically doing is if it's 6% compounded monthly, we want to know what percent would it be if it was compounded yearly. Let's use our formula. So we're finding the effective interest rate. We need to know I. I is 6%. And we need to know N. If it's compounded monthly, that means there are 12 compound periods in a year. And we're just going to plug those values in and find the effective rate. So 0.06 divided by 12 will be 0.005. Add it to 1. Then raise it to the power of 12, and then subtract 1. And you will get 0.0617. So the effective interest rate is 0.0617, which is 6.17% compounded annually. So what that means is that if we were to invest our money at 6.17% compounded annually, we would get the very same return as 6% compounded monthly. And if we do that with all of our nominal interest rates, change them into effective rates, then it makes it easy to compare all the different interest rates. Let's do some more examples. Our next example says find the effective rate equivalent to 4.95% compounded semi-annually. So again, this is the nominal rate. It's also called APR. And we want to find the effective interest rate. So we know the interest rate if it's compounded semi-annually. We want to know what that would be equivalent to if it was compounded annually. We know I is 0.0495. If it's compounded semi-annually, N is 2 compound periods per year. We plug these values into our formula, calculate this, and our effective interest rate will be 0.0501 or 5.01%. So a nominal rate of 4.95% compounded semi-annually would be equivalent to an effective rate of 5.01%, which is compounded annually. The next example says a credit card interest rate is 24% compounded daily. Find the effective annual rate. So this is our nominal interest rate, or also called our APR, and we want to find our effective interest rate. So we're going to use this formula. I is 0.24, and N, if it's compounded daily, N will be 365. So plugging these values into our formula, we get the effective rate equals 1 plus 0.24 divided by 365 to the power of 365 minus 1. We get 0.2711, or 27.11%. So 24% compounded daily is going to be the same as 27.11% compounded annually. The other thing I want to talk about is equivalent interest rates. Sometimes you're going to be asked to change a nominal interest rate to another nominal interest rate. So not to an effective interest rate, but another nominal. For example, it says what nominal interest rate compounded monthly is equivalent to 6.5% compounded semi-annually. The easiest way to do this is to use a function on your business analyst calculator, which I'm going to show you in the next video. But in case you need to know how to do it manually, I'm going to show you. So basically the interest earned has to be the same for either investment. We don't know what our principal is, and we're not going to worry about it because it's going to be the same. But when we multiply by 1 plus our interest rate divided by our number of compound periods to the power of our number of compound periods, it should be equal to 1 plus our interest rate divided by our number of compound periods to the power of our number of compound periods for the other investment. So in this case, if it's 6.5% compounded semi-annually, 1 plus 0.065 divided by 2 compounded semi-annually to the power of 2 should be equal to 1 plus the nominal interest rate we're looking for compounded monthly, so divided by 12 compound periods in a year, raised to the power of 12. And what we're going to do is solve for I, which involves a little bit of algebra. When I calculate this, I get 1.0661. Now in order to solve for I need to deal with this power, so I'm going to take the 12th root of both sides. So 1.0661 to the power of 1 over 12 will equal 1 plus I over 12. So when I take 1.0661 and raise it to the power of 1 over 12, I get 1.0053. Now I'm just going to move up here, and I'm going to write 1 plus I over 12 first is equal to 1.0053. I'm going to subtract a 1 from both sides, and I will get I over 12 will equal 0.0053. And now I'm going to multiply both sides by 12. I get 0.0641. So that means that 6.41% compounded monthly would be equivalent to 6.5% compounded semi-annually. In my next video, I'm going to show you how to use your calculator to change nominal rates to effective rates or nominal rates to other nominal rates. So when you're ready, take a look.